Well, hi, welcome to EC&M Tech Talk. This is a series of how-to videos brought to you by EC&M Magazine. We cover everything from codes and standards that affect our electrical installation to the equipment itself and on to practical applications that maybe we can apply out in the field then. And as I said, this is brought to you by EC&M Magazine. What you need to do if you haven't done it already is go to ecmweb.com. That's ecmweb.com. And then when you get to that home screen, look, there's a drop-down menu up in the upper left-hand corner. And go ahead and click on that drop-down menu. And the very first thing that you're going to see is for content that is special just for members only, a members-only portal. And what you want to do is you want to go ahead and click on that and sign up for that members-only portal. And it's free, okay? And what you'll find is, of course, not only these tech talks, but tons of other good information, everything from articles and videos and webinars and so forth, podcasts and everything related to different electrical topics. So you want to be sure and do that. ecmweb.com, members only portal, and sign up for members content. Righty? So I'm Randy Barnett. I'm going to be your facilitator, presenter once again for today. And today we're going to talk about energy codes and standards that apply to us out in the field. It's indisputable that the energy market is growing. You know, EC&M Magazine tells us that wind and solar installations are in the top 5 hottest market sectors for contractors. And we all know the challenges ahead with an aging electrical grid, instability of utilities. They can't seem to produce enough power. And I'm not saying certainly it's their fault. Just the system is aging and we need more infrastructure built if we're going to maintain our growing needs for electrical power. We've seen an uptick in the uses of electrical energy, haven't we? If we look at the electrical vehicle market, for example, some predictions are for an increased sales of electric vehicles for 6 million new vehicles this year, 2021. I don't know if we'll hit that or not, but whatever the actual number is, it's a lot of electrical vehicles that need to be charged. And I'm talking about cars that are vehicles that use batteries only. I'm not talking about the hybrids, okay? And so how are we going to take care of that market? Who's going to do that? The answer is the electrical industry is, huh? More advanced energy management systems are being installed in energy efficient buildings. Wind energy, solar photovoltaic, but wind energy has grown astronomically over the years, hasn't it? I mean, just look at the landscape as you drive across the country and you'll become a believer of that. Now, so we produce this energy, whether it's solar photovoltaic, okay, or wind energy, or whatever the source is that we're using to produce our power, and we don't need it all right then. So what better thing to do with it than to store it for when we do need it? So that's our energy storage systems we want to talk a little bit about today. Now, all of these topics that we just mentioned are all covered in the National Electrical Code. Okay? So, and I'm not saying any of these systems are perfect. You can't get something for nothing. If you want to charge the battery in your car, energy ultimately has to come from some source somewhere, doesn't it? Okay? However, if we look at how the National Electrical Code has changed over the last many editions in reference to the growing electrical technology that we now have present for renewable energy and energy storage systems and so on, and energy management systems, then it becomes obvious that there's a lot of opportunities. Opportunities for who? Anybody that's involved in the electrical industry then. When there's change, there's opportunity is one way to look at it. So what we're going to do is we want to look at some items out of the National Electrical Code. Once again, I'm going to be using the most current, which is the 2020 NEC. And we'll talk a little bit about some of the other codes and standards that are going to apply as well as we go through. But let's begin with just a little background on our code system then. So the codes, the first code, for example, building code that we had in the United States goes back to 1859 for the city of Baltimore. Codes and standards have grown a little bit since then, haven't they? I mean, 1897 was the first electrical code. And it was about a one-page document or something. And, not true today anymore, is it? So just like our codes and standards have grown, a lot of it is being driven by the changes in technology, isn't it? Okay? So let's take a look then at some of these standards and codes that have been changing in the NEC. And well, first of all, I'd like to begin with Article 750. Article 750 is a pretty short article, but it's on energy management systems. And we hear a lot about energy management systems, don't we? We see a lot of them. I mean, the lights go off in the building at 7 o'clock every night, or certain receptacles shut off in the building. Okay? So energy management systems and energy management control systems, those are all being installed by somebody with an electrical background, all righty? And we find a definition in Article 750 for our our energy management systems. And basically, those are any systems that are either going to reduce power, disconnect, put the power back on, and so forth, in order to save energy. So we shut off the lights. Lighting control is, of course, huge in the electrical industry these days, isn't it? So that's Article 750. Pretty much Article 750, without getting into it in the code book, it's very short, and pretty short anyway. And what it tells you is that watch out when you install those energy management systems. You want to make sure that you're not in any way interconnected with or interfering with the operation of emergency power systems, electric-driven fire pumps. I don't think I want that to be on any kind of energy management system. So it identifies some of those critical operations areas and things like that for us that are we do not want intermixed with our energy management system. So keep an eye on that. But let's go through then and take a look at some of our other articles. We've already talked a little bit about Article 625 in a previous Tech Talk. It's divided up into, 4 parts, I think. There's some general information, construction information, and of course the installation information for us. Now, it's not electric vehicle charging stations anymore. It's electric vehicle power transfer systems. Electrical vehicle power transfer systems. So here's some things to keep in mind if you're thinking about energy markets, something to get into then. These electric vehicles, we know that they're increasing, and they're going to be increasing even more and more and more. Okay, the numbers are going up quite a bit, even though because of other issues going on, we've seen declines in over the past couple of years in the regular automobile market, but we've still seen an increase in the electric vehicle market. So anyway, it's continuing to grow. Now, if I'm going to, they tell us another thing is that people tend to stay in their houses longer periods of time now after retirement. So, say somebody like me getting ready, thinking about retirement someday or whatnot, and I want to stay in my home, but gosh, I'd like one of those electric vehicles, and my home has been here for a long time. It tells me that if I get that electric vehicle, and with some other changes in technology that I'm probably going to do, I'm probably going to use 4 to 6 times as much electricity in my house. Wow, wait a minute, that's going to cost me some money. And I don't know if my service is big enough to handle this. And what about the grid? Oh, well, what about some renewable sources? We've seen a big increase in the residential solar market, haven't we, over the years? Okay. And then if I'm the contractor building a neighborhood of new homes and so forth, I wonder if I'm going to have these increase, if people are going to put these charging stations in their homes, then perhaps maybe we should, of course, install them in the homes already, but then what about in a neighborhood for a given number of homes? Maybe I should have some kind of energy storage system, small scale, to cover a few homes in a certain area, so that when people come home from work and they turn on the stove and the air conditioner or heat or whatever it is, depending on the time of year and all of that, and they plug in their electric car, they pull over the wireless pad, don't they, to charge their electric vehicle now. And so there's a lot of need for electricity at certain times of the day. So maybe to have that energy storage system available, not only to provide reliable power and the proper amount of power that these folks need, but to also be able to provide it at a reasonable price as well, So anyway, there's things to consider there. We've been through, as I said, electric vehicle charging stations, and so we will not go into it anymore right now. We do want to take a look at a couple others, though. Let's go in your code book we can take a look at Article 690 on solar photovoltaic systems. And solar PV systems, this has been in the code for quite a while. It's divided up into, what is it? I see 8 parts here. And general information, circuit requirements, disconnecting means. Now, it's important to realize that these parts that we're talking about are pretty well redundant in other articles relating to renewable sources of energy, like wind energy systems in the code as well. I have to have a method to disconnect my system. I have certain circuit requirements. Okay? Wiring methods and materials. Part 5 is grounding and bonding. Wow, that's pretty important, isn't it? Marking requirements on Part 6. Think about when I walk up to a disconnect, certainly as a fireman, if you walk up to a disconnect and you're going to shut the power off, is that the only source of power? Okay? Is it just the service coming into the building, or is there a disconnect for a solar PV system and so on? That's all covered in Article 690 then. Also, connections to other sources and energy storage systems that we're going to talk about as well. Now, Article 691, and so there's a lot of information in Article 690, and gosh, we don't even have time. That's another, 2 or 3 or 4 or 5 day training session there. Article 691 is on these large-scale photovoltaic systems, and they're 5,000 kW and up, okay? And they're not just controlled by the utility. So some large-scale systems that might be out there in the private industry and so forth is Article 691. Article 694 has certainly got a lot of attention over the years, and we've seen that grow, as I mentioned earlier, and that's on wind energy systems. Okay? So our wind energy systems, wind energy turbines, and it's usually, so it's not just the generator up there in the tower itself, is it? I also need to be able to transform that energy, have probably some type of underground distribution switchgear at the bottom of my tower that's going to take and send that energy to the transformer. All of that has to be installed, but it also has to be maintained, doesn't it? You bet. All of that underground distribution switchgear, transformers. Of course, the wind energy companies often take care a lot of what goes on up in the top of the tower, but as far as that distribution switchgear, we find that that's often contracted out to third parties then. So there's certainly some opportunities there in those distribution systems. But Article 694 has 7 parts to it. It's on wind energy systems. Then I really want to talk a little bit about Article 706, energy storage systems, because this is the area that's really growing in addition to the electrical vehicle charging. Okay? Energy storage systems. So I produce this power and I need to store it somewhere until when I need it. And so energy storage systems, most typically they're batteries, and they're probably going to be either lead acid type batteries or lithium ion batteries. That's most common. There are other types of energy storage, but Article 706 really concentrates on batteries being used for energy storage. Now, we have another article back in Chapter 4, and what is that? Article 480, I believe it is. 480, which is on battery systems. So don't get confused here. I have battery systems. For instance, I have a battery for my switchgear. I might have a battery room, certainly big battery rooms for a data center, battery rooms in a healthcare facility and so forth, large financial institutions and so on. All have these battery systems for uninterruptible power supplies. So they're really there for emergency systems. As compared to an energy storage system, that battery, it tells me, is there to supply power during normal operating conditions. So an energy storage system, I charge the battery up. So if I have something, like a 1 megawatt energy storage system, that means that instantly that storage system, those batteries can deliver 1 megawatt of power. For how long can they deliver that power? And the answer is it depends, of course, until they reach a certain discharge level, voltage level usually is what we're talking about there. But anyway, So our energy storage systems, typically lead acid or lithium ion, and they're there to provide normal sources of power. There are, about 6, 7 different parts in Article 706. It covers, once again, disconnects. Because you think about it, how do I shut off that energy storage system? I can disconnect the battery. I can disconnect the solar PV system. But I never can really shut that solar PV system off. If there's sunlight or light of some kind shining on that array, can I? The same is true with my energy storage system. I can't really shut those batteries off. I can disconnect them, but there's always going to be some energy in those batteries. So a big safety concern. Actually, safety for energy storage systems, if you go to nfpa.org, you'll find some separate information through the NFPA on safety for these energy storage systems then. And a couple of important things. Energy storage systems must be installed and maintained by qualified persons. We've got to maintain it. We need somebody to install it. We need somebody to maintain it. Whoever's going to do that, we're going to maintain it, it says, in accordance with the manufacturer's requirements, as well as there are other sources out there like the NFPA 70B standard. The NFPA 111 standards may be another example for you, and probably you're not familiar with this standard at all. But it's the standard on stored electrical energy for emergency and standby power systems. So that may come into play for you. Certainly 70B, which is our recommended practice for electrical equipment maintenance, soon to be a standard, by the way. Okay? So, qualified persons have to install and maintain these energy storage systems. Battery systems might involve an automatic transfer switch, disconnects, circuit wiring. All of that has to be installed properly. Signage has to be put on at the proper locations and so forth. What's a qualified person? If I go back to Article 100, it's going to tell me that somebody who has the skills and knowledge in the construction operation of their equipment that they're working on, and they've had some safety training to recognize the hazards and learn how to mitigate those hazards. So, qualified persons have to install and maintain my equipment then. It says 706.7 says I have to maintain my energy storage system. Who's going to do that? Somebody in the electrical industry is going to do that. Okay? And installation requirements for dwelling units and so forth is all covered in Article 706. Circuit requirements, circuit strings, and our circuit sizing, and the amount of current it has to be able to handle. Overcurrent protection is addressed. Charging control. I mentioned there's also another type of battery called a flow battery. I've never run into one, maybe you have. It pumps electrolyte into some electrodes, in between some electrodes. It's kind of like a generator in itself then, and it causes a chemical reaction to occur and generate electricity then. But those are covered, as well as the code also mentions something it calls other energy storage technologies, which could be anything in the world, couldn't it? Okay, whatever the new technologies are coming out, things that are already being used out there, all covered in Article 706. So anyway, that is kind of in a nutshell, covered a lot of ground once again, as we usually do in the National Electrical Code, but it really groups our articles for us, what we've talked about today, into this whole idea of energy, energy management, energy control, energy storage, being able to produce the power when we need it, have it available to us at reasonable rates and reliable sources then. So the main thing is that you go out of here and hopefully you get some ideas generated on some things that maybe you can take back and create some new opportunities for you, no matter what area of the electrical industry you are in. Review your codes and standards as you need to. And the main thing is, work safely out there. So, I'm Randy Barnett. Until next time, we'll see you in the next Tech Talk video.